function f of x equals the square root of 6 plus the secant of pi x squared. Oops, I closed that a little early there. Oh, that did not come out right. Let me fix that. I even wrote it wrong. X squared, pen troubles, is inside, and that's all inside the root. So we're going to try to take the derivative of this function. We're going to try and figure out what is f prime of x. So to do that, we have to identify an outer and an inner function. And I think this one you can kind of look at, it's pretty obvious. The 6 plus the secant is inside. The derivative of 6 is pretty basic, so I'm not even really too worried about that, but I'll state it anyway. So I believe that the inner function here is 6 plus the secant of pi x squared, and the outer is definitely the square root. Uh-oh, but wait. The secant has something extra inside of it there. Damn, darn. So it looks like this is not inner, but really middle. Okay, let's adjust a little bit. Just slide this down. My first guess was incorrect. That's really the middle, because inside the secant has that. So the inner is pi x squared. All right, so the order of operations for the chain rule, so when we do a calculation, right, we start on the inside and work our way out. Chain rule, we're going to start on the outside and work our way in. So the derivative of the outer function, I mentioned earlier, is one you should commit to memory. It's 1 over twice the square root of whatever. So that's the derivative of the outer. The outer happened to have inside of it a 6 plus the secant of pi x squared. So that happens to be inside the root. So that's the outer prime. Next, we're going to take the derivative of the middle function. So we multiply, sometimes parentheses are necessary. The derivative of 6 is 0, so I'm not even going to write it. So then I take the derivative of the secant. Anybody remember the derivative of the secant? Anybody still with me? Derivative of the secant is what? This is one you also want to commit to memory. To make your future life a little easier. All right, it is secant times the tangent. So secant times tangent. And what goes inside there is that pi x squared. So that's the derivative of the middle. And then last, we take the derivative of the inner and multiply that on. So times the derivative of the inner is 2 times pi times x. And then we attempt to clean up this fun stuff. So let's see, what do we got? Well, there's a 2 in the numerator and a 2 in the denominator, so that's cool. They will get rid of each other. Otherwise, I don't really see too much to do. So I'm going to take the pi x and write that out front. And then that's times the secant. So let's like do that over 1 and that over 1. Times the tangent of pi x squared. So I got that, I got that, I got that. I took care of that 2 down there, so that's gone, that's gone. So the last thing, I guess, is the square root in the denominator. 6 plus secant pi x squared. And I don't think there's much we can do to clean this up. Not familiar with a trig identity for secant times tangent. Pretty sure there's not one that makes it any better. 93% certain. Yep, done. Is it correct? The only way to check is to plug it into something like the derivative calculator, see if it agrees, or use this to find a slope to see if you can get an accurate tangent line of the original function here, like I've done previously. Are you not supposed to have square roots in the denominator? You know, in some cases, that is more of a fashion statement than it is a mathematical necessity. So we could rationalize the denominator. Oh, I don't want to do that. Okay, fine, we'll rationalize the denominator. So just a quick note on rationalizing the denominator and why sometimes it's a good thing and why sometimes who cares. Let's put up a new page. If you think back to trigonometry, the cosine of pi over 4 is equal to the square root of 2 over 2, which if you rationalize the numerator, you get 1 over the square root of 2. And which one is better? Well, this one uses less ink, even though it has the square root in the denominator. And the main reason people often rewrite it that way is because before calculators, you had to look up the square root of 2 in a book. And so you could look up the square root of 2 and cut it in half pretty easily, whereas taking the reciprocal of a crazy decimal is a lot harder. So the main reason people used to rationalize the denominator all the time is because they had to look up numbers like this in a book. But every once in a while, multiplying by a square root can clean things up. I don't really think it's going to here. So if we were to multiply top and bottom by the square root, I think this is just going to get messier. Oops. We'd have to do the same thing in the top. So then in the bottom, right, the square root cancels. So my denominator is now 6 plus the secant of pi x squared. But now my numerator is way more complicated. So now I have pi times x times the secant of pi x squared times the tangent of pi x squared times the square root of 6 plus the secant of pi x squared. So I guess it was worth looking to see if anything interesting happened, but nothing cancels here. I'm stuck with this square root in the top, and I've got way more ink. So I think this one up here is better, this green version, because it uses less ink. So I would say this is the best answer, but you don't know if something simplifies till you try something. So it's worth trying. So we tried here, it was a good suggestion, and we have a more complicated numerator. So we did get a little ink out of the denominator, but we added way more ink to the numerator to do so. Yeah, looking at that, it was worth trying, but yeah, the first version happened to be easier, but you never know until you try something. So thanks, good question, and we're out of time for fun with math. So take care, do homework, moving on to a new section tomorrow. So finish up this homework tonight to the best of your ability. You're welcome, have a great day.